Okay, so know how to find arc length, know how to convert from radians to degrees or degrees to radians. You can either use this equation where you plug in the angle in degrees here and the angle in radians here, or you can use dimensional analysis. So for example, 30 degrees to radians, so 1 pi radians equals to 180 degrees. So we cancel out the degrees, and that'll give you the radians. So 30 degrees equals to 0.52 radians. This is the equation for arc length. Make sure you use the angle in radians to get the correct answer. So the angle in radians equals to the arc length over the radius of the circle. Trig. So for this problem, you're going to find x1, add it to x2 to get this total x width. So you need to find, how do you find x1? You have the angle, you have the opposite length, and you want to find adjacent. So you use tan. Tan 63 degrees equals to opposite 82 over x1. So you can find x1 from this equation. And you can find x2 from this equation. Tan 39 degrees equals to opposite 82 over x2. So add x1 plus x2 to find x. Okay, vectors. Find vector a plus b graphically and algebraically. So I feel like a lot of students are comfortable with the algebraically, but maybe not so much graphically. So let's talk about that. So for the vector, you only look at the beginning to the end. Don't get thrown off by the coordinate axes. So start from the beginning of the vector. This is right for up 3. So right is positive in the x direction. So that's positive 4i. Up is positive in the y direction. So that's positive 3j. Okay, so vector A is equals to 4i plus 3j. Vector B, start from the beginning of vector B to the end of vector B. Don't get thrown off by the coordinate axes. So I'm going right 1 and down 2. Right is positive in the x-axis. So that's 1i, positive 1i to the right, down 2. Down is negative in the y-axis, so negative. I'm going down 2, negative 2j. So vector B equals to I minus 2j. How do I find A plus B in vector A plus B in ij format? I'm going to add the i's together and I'm going to add the j's together. So vector A plus B equals to 5i plus 3 minus 2 is plus 1. So 5i plus j. Here. Okay, so 5i plus j. Okay, that's algebraically. Let's do this graphically. The tail to tip method. Draw the tail of vector A to the tip of vector A. Then you're going to connect that second vector right away. You're just going to move this vector down to the tip of vector A. So just connect it. So I'm going to connect it to the tip of vector A. So tail of vector B to the tip of vector B. Now, how do I find vector C? Vector C is, I'm going to connect the tail of vector A to the tip of vector B. And that will give me vector C. So connect this vector B right at the tip of vector A. Okay, let's check. Is this C vector correct from graphical methods? It's 1, 2, 3, 4, 5 right and 1 up. So that's right is positive, so 5i. Up is positive, so 1j. 5i plus 1j. Yes, that is correct. It agrees with our algebraic method. Now you likely will be asked, how about a minus b? If this is b, then negative b is just 180 degrees to the other direction. It's the opposite direction. So if vector b is right 1 down 2, then negative vector b equals to left 1 up 2. So it switches direction. So right is changed to left, down is changed to up. So it's up to left 1. So same tip to tail to tip method. Tail of vector A to tip of vector A. Connect this negative b right away to the tip of A. So I'm being asked, what is vector C? Vector C equals to A minus B. Okay, so then to tail of vector negative b to tip of vector negative b. To find vector C, I'm going to connect the tail of vector A to the tip of vector negative b. So that's how I find vector C. Okay, so algebraically, instead of I minus 2, I'm going to get minus I plus 2. So the signs change. So I'm left 1 and up 2. Okay, so vector B is I minus 2j, negative B is negative I plus 2j. The signs change. Okay, so add all the i's together, add all the j's together. I have 3i plus 5j. Let's see if that is in agreement with our graphical method. So 3 right and 5 up. So 1, 2, 3. 3 right and 1, 2, 3, 4, 5. 5 up. Yep. Vector C is correct with what we found algebraically. Again, for vector C, you just look from the beginning of vector C to the end of vector C. That's all. So yes, 1, 2, 3. 3 right, 1, 2, 3, 4, 5. 5 up. I get from the beginning to the end of vector C. You could be asked, or you'll likely be asked, for magnitude of a vector and the direction angle of the vector. So you could be given a magnitude and an angle. So I'm asking for this problem, it could be any combination, but this problem asks, what is vector A plus vector B in IJ format? What is the magnitude of vector A plus vector B and the direction angle? All right, so you need to change each vector to IJ format using trig functions. So here, look at this. This is, what trig function would you use to get the horizontal I component? It's the adjacent vector. This is the angle, so it's adjacent, so it would be cosine. So vector AX is a cosine, so for cosine 30 degrees, the y component is 4 sine 30 degrees. Okay, let's go here. Let's look at the x and y components of vector B. What is the x component here? This is the angle, so this is adjacent. That's the x component. So that's 7 adjacent cosine. Cosine 50 degrees. All right, what sign is that? Is it a positive or a negative? I go left and then I go up to get from the beginning to the end of the vector. Left and up. left means negative. So the x component is a negative 7 times cosine 50 degrees. Let's look at vector b in the y direction. That's up, so it's positive. So it's 7 sine 50 degrees. Gives you the y component of vector b. Okay, so then you add all the i's together and all the j's to get the ij format for vector a plus vector b. After you get that ij format for the vector, then to find the magnitude, it's that square root of the x component squared plus the y component squared. Gives you the magnitude. And to find this theta, it is the opposite length over the adjacent length. So tan theta equals to y over x. Gives you this theta angle. Right? Okay, so direction angle. Depending on what quadrant is your angle. So for example, if your vector is in the first quadrant, that means that's a positive x and a positive y. Second coordinate means a negative x and a positive y. Third quadrant means negative x and a negative y. Fourth quadrant is positive x and a negative y. Okay, so after you find out which quadrant it is, then look for the direction angle. For quadrant 1, theta, this angle here, equals to the direction angle. The direction angle is clockwise from the positive x-axis. So it equals each other. For quadrant 2, or let's talk about quadrant 4. The vector will be pointing this way. This is theta. So it's the opposite over adjacent length. Is tan theta equals to the opposite over adjacent length. The direction angle equals to negative theta. So quadrant 4, theta, direction angle equals to negative theta. Since direction angle is clockwise, this is counterclockwise, so it's negative theta. Okay, quadrant 2. If this is theta, then theta A is clockwise from the positive x-axis, so it's 180 minus theta. We'll give you this angle here. How about quadrant 3? It's 180 plus theta. All right?